Welcome to this video on Properties of Exponents 1. This is for college algebra. This is Mr. Soto, and today what we'd like to be able to do is to learn about the properties of exponents and how to use them to simplify expressions, and learn about rational exponents and how they are similar and different to integer exponents. And in fact, today, this video specifically will focus on the first goal, which is we want to learn the properties of exponents and how to use them to simplify expressions. And so we'll start first with looking at the properties. These are the properties that I would like you to be able to memorize for your next exam or your next quiz. And of course, some of them you already know and you've seen before. So what I would do at this moment is maybe pause the video, go online to Icon, and look for the handout that says properties of exponents, and it will have this sheet for you. You can print it out, and then you can go ahead and have it with you as you try to learn all these exponents. Now, a couple of things to notice here. One of my favorite rules that gets used a lot is any number to the 0 exponent is equal to 1, as long as the base is not equal to 0. We don't know what 0 to the 0 is. One that most of you are familiar with is the product rule. If you have two bases that are exactly the same, and if you have two different powers, you can go ahead and add the powers. This one's also a very useful one. If you're dividing two numbers that have the same base with different powers, you can subtract the powers. The one that we've used before is I've told you that a negative exponent is also the same as the reciprocal, and that's what this notation means right here. And then these three are extremely useful, and so we'll use these in all our problems. So let's try an example. Using the properties of exponents, we will simplify the following, and they want to make sure that we write our exponents using positive exponents only. So to give you an idea of what these rules mean, this first thing is that I want you to look at this cubed, and that cubed means that we want this expression 4x squared y, we want to multiply it with itself 3 times. So one long way to do this is to write it like this. This is really 4x squared y times 4x squared y times 4x squared y. And so I'm going to do this the long way, but eventually I do want some shortcuts. The shortcuts would be a lot nicer. And so here, what will happen is that, notice, because of the commutative property that we learned at the beginning of the year, we can rewrite this as follows. This is all multiplication. All of these are multiplications. Every single one is a multiplication. And so we can rearrange every term so that it looks like this. 4 times 4 times 4 times x squared times x squared times x squared times y times y times y. And these are, again, all times. And so notice that 4 times 4 times 4 is 64. Then I count the number of x's. This x squared means there's 2 x's, there's 2 more here, and there's 2 more here. So that means I have 6 of them. And then finally, there's 3 y's total, so I write y cubed. So the final answer is 64, x to the 6, y cubed. But what I wanted you to see is, again, the shortcuts. Notice that you could have cubed the 4, and that, because you get 3 4's, and that would have given you 64. When you cube the x squared, you get 6 x's. 3 times 2 is 6. And then here, there's an exponent of 1 that we never write. If you cube the 1, if you cube the y to the first, 3 times 1 is 3, and that's how you get this 3 over here. So we're going to look for shortcuts. Again, I'll do them long way the first time, but I do want you to start looking for some shortcuts so this can be a little bit faster. Next example. So here, if we try this the long way, again, we're cubing. And so we have to cube this expression, so that means that we want to write it 3 times, and it's all multiplication. So 6x squared over y times 6x squared over y times 6x squared over y. Or, because of the commutative property, we can write this as 6 times 6 times 6, x squared times x squared times x squared, and then in the denominator, y times y times y. So that means that we get 6 cubed, because there's 3 6's, 6 cubed, x to the 6 over y cubed. And so now what we can do here, 6 cubed is 216. X to the 6 is just x to the 6, and then here the denominator is y cubed. And we can leave our answer like this. Notice that the directions did say that they want the exponents to be positive only, and so this would be the best way to write the answer. Okay, so let's go on to our example. Using the properties of exponents, we want to simplify this again, and now we have a negative exponent. So here's how this changes. Here, this negative exponent that I see at the beginning, this negative 3, what it tells me to do is find the reciprocal. So I should think of this as 1 over, parentheses, negative 2x squared, y squared, all cubed. Okay, well, how does this help? Well, at least now I don't have negative exponents. And again, I can go through the same process. But now, hopefully you've gotten on to the shortcut. You cube the negative 2, so that's negative 2 to the third power. We cube the x squared, so that's x squared to the cubed. And we cube the y squared, so that's y squared cubed. Again, hopefully you're catching on to this, to these shortcuts. So now you can say, well, I know that negative 2 times negative 2 times negative 2 is negative 8. I know that x squared times x squared times x squared is x to the 6th. And I know that y squared times y squared times y squared is y to the 6th. And notice all the exponents are positive. So this works really well. Okay, one more example, and then we'll stop this video. Again, we're going to use these properties. And so now we have negative exponents all over the place. And we even have a 0 exponent. We have a 0 exponent here and a negative. Now, one of the things that makes rules of exponents a little tricky is the fact that there's many ways to solve these. So I'm going to show you one way to approach this problem, but there actually are very many. Okay, number one, the way that I would attempt this problem is I would work on the inside first and ignore the outside exponent for a little bit. And then, so I have x squared here. And then the 3 is just fine. The x to the 0 is 1, so I'm going to write times. So this x to the 0 is equal to 1. So I write 1. Then I have y to the 5th. And then reciprocals, excuse me. Y to the negative 2 really means take the reciprocal of that, so that means I bring it down here, y squared. And so now, when I simplify this, I have x squared in the numerator. In the denominator, I have 3 times 1, which is just 3. And then y to the 5th and y squared means 5y's and 2y's. So again, I'm going to write it here on the side. Y to the 5th times y squared really means 5y's times 2 other ones. Well, that means there's 7 of them. And so instead of going through all this process of writing them out, we know that 5 plus 2 is 7, and that's one of the rules that you have on your other paper. Okay, so that means we have y to the 7th here, and then an exponent of negative 2. But we know that negative exponents means do the reciprocal. So the reciprocal of this is 3y squared over x squared, and then we change the negative exponent to a positive. We took the reciprocal of this fraction. All right, we got the reciprocal. That's not a problem. And now the square says square everything on the inside. So that means I get 3 squared times y to the 7th squared times x squared squared. One last simplification. We know that 3 squared is 9, so that becomes 9. Y to the 7th times y to the 7th, that's y to the 14th. X squared times x squared is x to the 4th. And there's our answer. I hope this helps with your first assignment, and I'll have the next video for the second one.